right, let's take a look at 8.1, looking at polar coordinates. So far we've thought of points as XY pairs. So those are rectangular coordinates. Okay, so we think of an XY pair, say 2, 1. That's called rectangular coordinates because, let's see, I think of a rectangle as in I go right 2 and up 1 to plot that point. So what we're doing in this section is we're thinking instead of in terms of an X and Y pair about an R and a theta pair. So a given radius and angle. So polar coordinates. Thinking about a radius and an angle theta. Okay, so I tried to draw a decent coordinate plane here, but what I did really is, I just labeled the angles that we know, and then I put in these, here's a radius of 1, radius of 2, radius of 3, etc. Okay, so now I'm going to plot, say, number 1 here. All right, so number 1, my radius is 2. My theta is pi over 2. So what I like to do here is I like to find the angle. Okay, so here's pi over 2, right? Then I go 2 units, so 1, 2 units. There's my radius of 2, my angle of pi over 2. So there's point number 1. What about point number 2? Okay, so I'm going to find my angle, 3 pi fourths. That's here. My radius is 4. So 1, 2, 3, there's that point. Okay, problem number 3 here. The angle's 7 pi. Okay, so 7 pi, remember that's 6 pi plus 1 pi. This is 3 full times around the circle, right? So in other words, 7 pi is coterminal with just pi. So that's here. And then the radius is 1. Okay, so there's point number 3. Okay, number 4, we've done these before where I have a negative angle. That just means I go clockwise. So I'm going to go that direction, right? So there's negative pi over 3. And the radius is 2. It's here. Okay. Okay, what about a negative radius? Okay, so same thing. First I'm going to find the angle. The angle's pi over 2. Okay, so the one I'm plotting now is this one, this guy, right, for reference. Okay. Should I change my color maybe? Let's do this guy in red. So I find the angle, pi over 2, but then because the radius is negative, instead of going 2 units towards pi over 2, I'm going to go the opposite direction. So 2 units this direction. Okay, so here's my point number 5. Okay, so one more time. How did I do that one? I found the angle pi over 2, that's up here, but then I went 2 units away from that angle. So instead of going 2 units up, I went actually 2 units down. Okay, what about number 6? So another negative radius. So I find the angle 3 pi fourths. Then I'm going to go the opposite direction. So now I'm graphing this guy. Okay, so I find 3 pi fourths. That's here. But instead of going 1, 2, 3, 4 units along that angle, I go the opposite direction. 1, 2, 3, 4 units. Okay, so there's point number, what is that, 6? 6. And then one more, number 7. Okay, so again, -1 7 pi would be coterminal with -1 pi, right? So if I find pi, it's here, then I go the opposite direction. So here's point number 8. Oh, oops, number 7, huh? There is no number 8. There we go. Okay. So one interesting thing with polar coordinates is that there are actually multiple ways to represent a point in polar coordinates versus with rectangular coordinates, there's only one way to represent a point. So here I have an r theta pair, so say -2, -7 pi 6. And my goal is find 4 other representations. In other words, 4 different ways to get to the same point. Okay? Now it says 2 with a positive radius and 2 with a negative radius. So first let me find the point. Okay, so I have to find the angle -7 pi 6. So that'd be here, right? Okay, and then 2 units out. So radius of 2, point would be right here. Okay. Okay, so this is my r theta. Okay, now the thing is, no matter how I think about this, I mean, this guy is a distance of 2 units from 0 here. Okay, so the only possibilities I could think of for my radius would be, either +2 or -2. Because that radius has to be 2 at least in magnitude. Otherwise, I'm not going to get this distance of 2 units here. So the thing I can really play with to get all of these other representations, actually as many as I want, is I can play with that angle, right? So what could I do? Well, I could add or subtract 2 pi, right? So let me think. So if I'm at -7 pi 6, let me see what I can do. I mean, I can add 2 pi. So what is that? 12 pi 6? So that would be 5 pi 6. And then let me check. So we're saying another way to get to the same point would be to find the angle 5 pi 6 and go 2 units out. Okay, looks correct. Now, I mean, I could add another 12 pi 6 to that. So So that'd be 17 pi sixths. So I mean, I could do that one. That works. Maybe not all that interesting. So I guess my other thought, or another thought, would be, what if I take that negative 7 pi sixths and I instead subtract 12 pi sixths, 2 pi, so negative 19 pi sixths. Okay, what about the ones with a negative radius? So in that case, well, let's see if it'll let me do that. I think it might not. Let me erase the blue one. Not really. So, in this case, what I'm really thinking of this time is, well, how do I get to this point? Okay, that angle, right? So like one way I could think of that angle would be negative pi over 6. So what if I put that here? Let's see if that works. So to plot this point, I would be saying go to negative pi 6, okay, but go the opposite direction by 2. Oh, look at that. That puts me at the correct point. Okay, now I can take that negative pi 6 and I can add or subtract 2 pi. So 11 pi 6 would be another way to get to the same point, wouldn't it? Okay, and I can just keep on going those angles if I wanted to. What about converting? Convert each pair of rectangular coordinates x, y to polar coordinates r, theta. So let me just think kind of in general for a second here. If I have a point, say my point is here. I'm just thinking in general. Here's an xy pair. Okay? And I'm thinking, well, how could I convert this into an r theta pair? Well, the thing is, there's a right triangle hiding in here, isn't there? So I'm interested in, how do x and y compare with r and theta? Well, wouldn't it be true that x squared plus y squared is r squared? That's just the Pythagorean theorem. And wouldn't it be true that tangent of theta is y over x? That's the definition, right? So here's a little pair of equations that I could use to convert rectangular coordinates to polar coordinates. Okay, so look back at the example over here. I mean, if you want, a rough sketch. Here's the point 2, 2, right? So my goal is, can I figure out the r and the theta? But wouldn't I just set up, let's see here, so 2 squared plus 2 squared is r squared. So r squared is 4 plus 4. So I have 1 4 plus another 4. I have 2 4s. Take the square root. Square root of 4 is 2, so 2 root 2. Okay, and then tan theta is 1. Okay, I can see theta is in quadrant 1, so pi fourths. Clean some of this up, a little bit more room. These were my general equations here. Okay, so then I would say, therefore, if xy is 2, 2, then r theta is 2 root 2 pi 4ths. Now, remember we said, well, there could be different ways, different representations of the same point in polar coordinates. So I guess usually you'll see something in the instructions kind of limit us to one answer. You'll see something like, let's add here, polar coordinates are theta, but let's say with r greater than 0 and theta belongs to 0 to 2 pi. That's just saying we can't do anything creative with our answer. Like you see how over here where I took the square root, I could have used the negative. Here I could have added or subtracted 2 pi, been creative. So when we add these stipulations here, that's just limiting us to the most basic answer, okay? Which is the one that I gave. Okay, let's see. Here's another one then. So I would say at least get a rough sketch. I at least want to know, what quadrant that I'm in. So this guy, let's see, looks like it's in, is it quadrant 3? So it doesn't need to be to scale, but let me see. 3 root 3 is bigger than 3, right? So I don't know, I'm just looking at a label. I'm going to call this -3 square root 3. And then I'm going to call this and a -3. So then here's my point, okay? So then I'm kind of thinking this is a reference triangle. So what I'm looking for is the r and the theta, okay? So I set up my two equations. Let's see, so the Pythagorean Theorem. So that's what, 9 times 3 plus 9. So what I like to do with that is I like to say, okay, I have 3 times 9 plus 1 times 9. I have 4 times 9. That way when I take the square root, I just take the square root of each of those factors and I have my r directly. That saves me from having to deal with big numbers. Okay, and then y over x. Rationalize. Okay, now be careful, because here it looks like theta would be pi 6, right? But look at the picture. That's why it's important to do a sketch, because I'm actually in quadrant 3, not in quadrant 1. So I know theta is actually 7 pi 6, not pi 6, okay? Okay, so then let me write out my pair. So then my r theta pair is 6, 7 pi 6. Okay, what about going the opposite direction? Convert each r theta pair to xy. Okay, should I do kind of a generalization again here first? So let me just think then. So if I was going to graph an r theta pair, so that means I find my angle theta, and then I go out a distance, of r here, right? And there's my r theta point, okay? But you can see what I have here then, I have a right triangle. This time my goal would be to find the x and the y. Okay, so can't I do that by saying something like this? Let me look at the cosine of theta. Wouldn't that be x over r? Wouldn't the sine of theta be y over r? Oh, look at that. So there I have a pair of equations for converting our theta to xy. These ones are actually really easy to use. So if you look at this first example, I mean, I can do a sketch. Okay, so I find pi thirds, 60 degrees, and I go out, 2 units. There's that point. Okay. So this is pi over 3. And then the goal is find, x and y. Okay, but I'm just going to use these equations. Really easy. So I would say, let's see, x is r cosine theta. Y is r sine theta. Okay, so cosine pi thirds, 1/2. Oh, look at that. So then I have my xy pair. Okay, so if you look at the picture up here, so that's just saying another way to get to the same point would be go right by 1 and up by square root of 3. So I can use those same equations here. Okay, so then my xy will look like so. All right, what about something where I have an equation? And I want to convert each equation to polar form. So this is a little different because I'm not dealing with a point, I'm dealing with an equation. And so right now, this equation, is written in rectangular form, that is in terms of, say, in terms of x and y, okay? So the goal then is, if my goal is to get this guy in polar form, that means that my equation can have r, let's say, and or theta, but not x and y. So my goal is to get rid of x and y, okay, and get instead r and theta. So let me think about this guy for a second. I mean, what are some things I know? So remember some of those equations? I think we established 4 equations up above that really relate x and y and r and theta. So we had this one. We had this one. So I'm kind of looking at this equation number 1 and I'm thinking, well, I wonder how I could use these guys. I'm seeing this one. Like, what if I take equation number 1 here and I divide by x? Because isn't y over x tangent? So then I'm thinking, okay, so what is the angle that has a tangent of square root of 3? Isn't that, let me do it this way. Pi over 3 or 60 degrees? Okay, so there's my equation written in terms of theta instead of in terms of x and y. Now, if I actually graph this, it kind of makes sense. Clean this up a bit. Oops. There we go. I was trying to move that down. So, look, if I have y equals root 3x, okay? This is a line, isn't it? So if I was to graph this, I mean very roughly, let's see, starting at the y-intercept of 0, 0, go up by 1.7, right by 1, you know, down by 1.7, left by 1. Okay, it looks something like that, wouldn't it? Okay, so what we're saying is, we're saying I can graph that line thinking about the slope, that's what I just did, or look, if I say theta is pi over 3, that's saying all points where the angle is fixed at pi over 3, right? So any points where I have a positive radius would be accounted for here. Anywhere I have a negative radius would be accounted for here. So actually what I notice is I can kind of make another little generalization, which is, you see how here, anytime I have a line, I know in polar form that's going to be theta equals a number. See? So if theta equals a number, my angle is fixed. I'm dealing with a line. Okay, so if you look at number 2, I have another line, don't I? So I could tell you immediately then my answer is going to be theta equals something. Okay, because I know dealing with a line. So I could use that same trick where I divide both sides by x. The only thing is, well, this one, it's not a special value. See how up here, I know the inverse tangent of square root of 3 is 60 degrees because that is a nice value. Now, I don't know the inverse tangent of 3. So I guess I could actually, as far as an exact answer, I could leave my answer like this. This is an exact answer. That would be a test answer. Okay? Now on the calculator, I could get an approximation. I think that was about 72 degrees. And that would just be in terms of the worksheet. Okay, so if I was to plot, to graph that line, I mean, let me see here. The slope is 3, so it's here, here. It's like so. So you can see that one, the angle's more than 60 degrees, right? Okay, what about vice versa? Convert each equation to rectangular form. So that means my goal is get x and or y, but not r or theta, okay? But I have these same four equations that I'm working with. I don't know, can even move them down here. Would that be useful? Same four equations, okay? So, all right, here's the first thing I notice about number one. It's a theta equals, I know this is going to be a line, because look. Here's theta equals pi fourths. We'll use a different color, huh? Looks like that, doesn't it? That one's really easy. I bet you I can tell you the answer. Okay, but how would I show this? I mean, what if I was to use, say, this equation? But what I'm going to do is I'm going to take the tangent on both sides then. Okay, I know tan of theta is y over x. I know tan of pi fourths is 1. So wouldn't it be true that the equation of that line would be y equals 1x? Oh, look at that. The slope is 1, isn't it? What about number 2? Number 2 says the radius is 5. This one's a really easy one. Okay, so should I try to graph that? So this is saying all points to extend my coordinate plane here, but I think you'll get the idea. Saying all points that are radius 5 units from 0. So wouldn't that be all of these points? Theta can be anything, right? The radius is stuck at 5, yeah? So what kind of shape is that? Oh, that's a circle. I mean, I'm using this equation, but can't I tell you the equation of that circle is just x squared plus y squared equals 25? Okay, what about number 3? So again, I'm kind of looking at the equations and I'm thinking, well, what does this look like? Well, I see r cosine theta right here. Oh, isn't r cosine theta x? Isn't that just x equals 5? I mean, x equals 5. Isn't that just a vertical line? Okay, there's the line x equals 5. Number 4 is the more interesting one, I think, because I don't actually see any of the equations in there, at least directly. So the thing is, I mean, when I'm looking at my equations, Okay, if I had an r in front here, I could use that third equation. If my r on the left were squared, I could use that first equation. So I kind of have to do some sort of preliminary trick. So I'm kind of thinking, I mean, what if I try something like squaring both sides? If I did that, I'd get r squared is something like this. Okay, this side would be good, but the right side I'd still be stuck, okay? So what's another idea? So maybe instead of squaring both sides, I'm like, well, what is another way I could get the r squared on the left side? Because that r squared on the left side here seemed to work. It was the right side that didn't work. So what's another way I could get r squared? What if I try multiplying both sides by r? Will that work? Okay, well, let's see. So what can I use then? I can use equation 1. Oh, and equation 3. So wouldn't this be x squared plus y squared? And wouldn't this be 2x? Because r cosine theta is x. Okay, so now I've achieved my goal as far as getting rid of r and theta and getting x and y instead. Now my question would be, well, how can I graph the shape? So I'm kind of thinking about this shape, and I'm thinking, I recognize this shape. This is a circle. Now, this 2x, this linear term, shifts the circle. So it's a shifted circle. So do you remember the standard form equation of a circle? Looks like this. Okay, that was a circle with a center at the point HK. So my goal is put this circle now in standard form by, and the process we used was completing the square. Now we used this process already. We were taught when we talked about, well, we did at least one circle in 10.8, but we did this with quadratic functions as well. So let's see if I remember some of the steps. Okay, so I have my x squared plus y squared is 2x. So let me arrange this. Let me put this 2x next to, the x squared. So what were some of my steps? Move the constant. So there's no constant here. In other words, that's like, there's like a plus 20 here. I'd move it over here. Okay. Let's see. Then I had to look at the squares. So I had to divide by the lead coefficient if it was not 1. Now you see how these guys already have 1s in front? So that's already done. This is an easy one. Okay. So now I go ahead and I go to my next step, which is adding my special number, b over 2 squared. Of course, I have to add that on both sides. Okay, now this one I'm only looking at the x's because see how the y's, there's no linear term. So what is that number going to be? Let me see. So I'm going to add that 1 on both sides. and then I'm going to factor. Now y squared, that's just y minus 0 squared, right? So there's my circle, written in standard form. And so now I could graph that. Guess the center is at 1, 0, and the radius is 1. So it would look something like that. So that was the more interesting one.